Hello students, in this video we are going to discuss about activity on the topic chi-square test. So before we'll start with the activity based on this particular test, I'll just brief you about the chi-square test. Basically, chi-square test, if we talk about chi-square is a square of the standard normal variate, right? So it is also used for the test of the homogeneity of the variances. But in this particular video, we are going to discuss about chi-square test as a goodness of fit. So this is one of the important and powerful tests for the significance of discrepancy between the theory and the experimental. So with the help of this test we can check that either there is any discrepancy or you can say that significant difference between the observed value or the calculated value, experimental value or the theory value. Is there any significant difference between them? This thing we can test with the help of chi-square. So in this case, if I say that OI is the observed frequency and EI is the expected frequency. Expected frequency means on the basis of certain theory we are expecting that this should be the value, and OI is the observed frequency, means that we have conducted some experiment, on the basis of that we have calculated some value there, right? In that case the value of the chi-square statistics is given by the formula summation. Here the value of phi varies from 1 to k because I'm assuming 1 to k, so it is OI minus EI whole square divided by EI, means OI is the observed frequency, EI is the expected frequency. So the formula of the chi-square statistics is, firstly we calculate observed minus expected frequency square, and then we divide it with the expected frequency, and then we sum up all the values from 1 to k. That will follow chi-square distribution with n minus 1 degree of freedom or k minus 1 degree of freedom if we are considering the k different observations. It will follow chi-square distribution with k minus 1 degree of freedom. So we'll compare this value at the given level of significance. According to that we are going to accept or reject the null hypothesis, right? So in this case the null hypothesis is same, like there is no significant difference between the observed and the experimental value, and the alternate hypothesis we can assume accordingly, like either there is a significant difference between them, right? But like I told you that what is a chi-square? Chi-square is basically the square of the standard normal variate. So when we study that chi-square distribution, then we'll get this one, and we know that z-square is a standard normal variate, which is a normal distribution. So when we take the square of that distribution, then it will gives us a right distribution only. That means it is a right-handed skewed distribution. So in this case we are not getting any negative values. So if we just look at the type of the distribution, then this is the kind of the distribution we have, the chi-square, and in this case we are given a table as a right tail value only. So even in this case we can calculate the value for the two tail. So if I want to calculate the chi-square for two tail test, so in that case at alpha percent level of significance, then we can consider the value alpha by 2 from right hand side and alpha by 2 we calculate from the left hand side, and on the basis of their difference only we can get the region of acceptance, right? You can see here 0.995 means at 5% from the left hand side its value is given here, and this is 0.005. so basically this is approximately 0.005. so it is 0.5%, right? So 0.5%, 0.1%, and accordingly we are given this value. So it means that this side, the right handed side, means 0.995% of the area, 99.5% of the area falls in the right hand side. This is the meaning of this part. And if we come out here, that chi-square at 0.005 means this is the about 0.5% of the area is in the right hand side. Okay, generally we are testing the hypothesis at 5% level of significance. In that case right tail, we are using this value chi-square at 0.05. okay, and if I want to calculate corresponding left tail, so in that case we prefer 2.5% from left hand side and 2.5% from the right hand side. So we can consider these two value for the same. Okay, so we'll take an example. So on the basis of that only we'll try to see that what will be the result of that activity. So let us come to the activity part. So the first thing is, when we are going to perform the activity, we need to understand that what is the condition for the validity. The first condition for chi-square test is sample observations are independent. All the constraints on the cell frequency, if any, it should be linear. That means this is the necessary condition, that the sum of the observed frequency and expected frequency should be same. The next condition is the total frequency should be reasonably large, that is it should be greater than 50. What is the meaning of this capital N? For example, I say that OI is the observed frequency. So if we sum up all the observed frequency, then the sum value should be at least 50, means it should be greater than or equal to 50, right? Similarly for the expected frequency, but the condition is observed frequency sum and expected frequency sum should be equal. Another condition is there is no theoretical cell frequency should be less than 5, means like the observed frequencies, for example, we have 17, 15, 8, 5, 2, like this. So in that case the condition is none of the cell frequencies less than 5. So it means that if there is any cell frequency less than 5, then because the chi-square distribution is a continuous distribution, okay, so if the value is less than 5, then it will break the continuity. So in that case what can we do? We merge these frequency, we pooled these frequencies so that any cell frequency should not be less than 5. So on the basis of that we'll find out here. So in this case if I count, the total number of observations are 5, but when we pooled them, then we left with a 4 observation only, so it will reduce our degree of freedom also, right? Okay, so let us come to the activity here. So for this activity we are going to consider the data of the last digit number of mobile number of the students, right? So we have collected this data, and in this data we have around 1706 entries are there. Okay, so in this case what will be our null and alternate hypothesis, and what we are going to do in this activity? Let me firstly demonstrate here. So in this case our firstly null hypothesis will be, the null hypothesis will be the all the digits are uniformly distributed. Digits are uniformly distributed because we have considered the large data. So I'm assuming that if we randomly we are assuming that the digits 0 to 9, it should be uniformly distributed, they must be occur equal number of times, right? What is the alternate hypothesis in this case? They are not uniformly distributed, right? So generally we are considering, because like I told you, chi-square is a right-handed distribution only, but we can apply one tail or two tail test in this case. Okay, so for example, if I choose the level of significance alpha as a 5%, okay, so if we apply one tail test only, then we are assuming that we are going to remove 5% from this side. So what does it mean that? So in this case we are saying that some of the digits are they are repeated more number of time than the other one, right? Or when we are saying that they are not, it means that if 5% level of significance is there, it means that 2.5% we are removing from left hand side and 2.5% from the right hand side. So we need to calculate the probability of chi-square at 0.975 as well as chi-square at 0.025, right? So because it is a right-handed distribution and the given degree of freedom also, right? So, and what about the test statistics? In this case the test statistic will be chi-square is equal to summation observed frequency minus expected frequency square divided by the expected frequency, right? Now because in this case we are given the digits, so digits are basically from 0 to 9, 1 2 3 4 5 6 7 8 9. So the total number of possible numbers are 10 only. So in this case degree of freedom will be n minus 1, that is 10 minus 1 is 9. So I need to check the value of chi-square at this level of significance and this degree of freedom, right? We need to check two different values here. So if I look at this one, so 0.975 at 9 degree of freedom, its value is 2.700, and at 0.025 its value is 19.023. so 2.7 to 19.023, 2.7 to 19.023, yeah, 19.023. okay, if we are applying two tail test, if we are applying only one tail test, then its value is 16.919. so I'm expecting that if the value is less than 16 chi-square is 16.919, means if the value is less than this one, this is the case of right tail test and this is the case of two tail test. Okay, so in this case your distribution is like this. Okay, so let us apply this particular test on this data. So the first step is, because we are given the digits between 0 to 9, so firstly I need to find out their observed frequency. So firstly I need to count that how many times these digits are repeated. So I'm considering here the digits only as 0 1 2 3 4 up to 9. so let us drag this number up to 9. Okay, now I want to calculate the observed frequency, that how many times these digits occur. So we can apply the command of count if the range is from here to last one. And what is the criteria here? The criteria is I want to see this number. Okay, again, because I will need to calculate other also, so I want to fix that this range will definitely started from this particular point only. So I'm using here the $sign. Okay, so that will gives us the total number of times 0 appear is 176, and this is the total number of times the digits are repeated. So if I calculate the sum, so sum comes out to be, because I need this information, control shift down, so 1706, this is the observed frequency. So what is my expected frequency? So my expectation is that all the digits are uniformly distributed, means all the digits should be repeated equal number of times. So for that, what I am expecting, that if 1706 is the total frequency, so I'm expecting that all the digits should be repeated 170.6 times. Okay, although it is not the exact number, but I can expect that so that the total observed and expected frequency should be same. So all the digits are uniformly distributed. This is my expectation. So now if I simply show you the criteria, that what we are actually doing in case of chi-square. So the first step is we are doing, if I represent observed frequency as OI, and if I represent the expected frequency as EI. So first step, I need to calculate OI minus EI, its square, right? And then I need to divide this particular term by EI, divided by EI, right? So let us firstly calculate this term. This is equal to bracket observed frequency minus expected frequency, and then its square. Then in the second part I'm going to calculate this term divided by expected frequency. Now I'm going to drag this value, and now I'm going to drag this so that I can get the value of observed minus expected frequency. So what is the value of chi-square here? So the value of chi-square comes out to be, that is summation observed minus expected square upon expected. It comes out to be 5.28956. okay, and you can see here like its value comes out to be 5.28956, 28956, and we have seen from the table itself that this value falls between these two numbers, right? Because the chi-square calculated, it falls between the calculated value, tabulated value 2.7 and 19.023. so it means that null hypothesis accepted. Null hypothesis accepted. Either we apply two-tail test, in this case this is the acceptance region, in case of two-tail this is the acceptance region and this is the rejection region. So because the value falls between these two numbers, so it means that this falls in the acceptance region. So it means that null hypothesis accepted. So what can we conclude here? That all the digits are uniformly distributed. Okay, so this is the process of performing the testing of hypothesis. Now I have done this manually, but otherwise if I want to do the chi-square testing of hypothesis, so we can simply use the command of chi-square test. So what it expect two things. One is the observed frequency. I need data up to 11, and other thing is we are needed the expected frequency. Control shift down, but up to 11. So it will gives us the probable value. This is the probability that chi-square is greater than this one. So if this is the probability value, this is the probability that chi-square is greater than chi-square alpha is equal to 0.808371, right? And if that means that about 80% of the data falls in the right hand side. This particular side we have a 80% of the data, right? So it means that 20% this side, so it means that definitely more than 2.5% from this side and more than 2.5% from this side. But if I need a value, so I can calculate the value also. So I can apply inverse right tail, or if I want to apply two tail, then we can simply apply chi-square distribution, right? Chi-square inverse. I use this value and the degree of freedom will be 9. So it will gives us the value at 12.40111, but basically I need for right tail. So in that case I can use chi-square distribution right tail, inverse right tail, and this is the probability, and the degree of freedom is 9. Degree of freedom is 9. So you can see here its value comes out to be 5.289566. So basically this value comes out corresponding to the right tail only. Okay, because in this case this is the region of rejection, right hand side part is the region of rejection. So with the help of this particular command we can directly get the value of chi-square. So there is no need to perform this calculation if I am using Excel. So with the help of the command of chi-square, which command we have used here? We have used chi-square test, observed frequency, and this is for the expected frequency. It will give us the probable value, and if we need the value, then we can use the command of chi-square inverse right tail. So what is the probability value and what is the degree of freedom? That will give you the value also. Okay, and if we want to check the value, that for example the tabulated value, then we can use the command of chi inverse right tail. For example, I read for 0.975, and here I use 9 degree of freedom, that it will gives us the left limit also. And to calculate the right limit, we can use chi square right distribution, but the degree of freedom is 0.05, and the 9 degree of freedom, sorry, I need inverse formula, right, inverse right, but this time the probability is 0.05 and 9 degree of freedom, so it will gives us the 0.025. so for two tail it will gives us this limit, and if I need the value for a right tail only, then chi square inverse right tail, then we are considering 5% on the right hand side. Okay, what is the meaning of 5%? Means we are considering the region of rejection as a 5% on the right hand side only. Means if this is the chi-square distribution, then 5% we are rejected from the right hand side only. Means 95% is the region of acceptance. Okay, so it means that if the value is greater than this number, if the value is greater than this number only, then we reject the null hypothesis, and if the value is less than this number, then in that case we are going to accept the null hypothesis. Okay, so in this case, because the value 5.28956, it is smaller than this number, so we are going to accept the null hypothesis. So what do we conclude from here? That we can conclude that all the digits are uniformly distributed. So this is the learning from this particular activity. Okay, I hope you understand that how can we apply the chi-square test on a data, how do we calculate the observed frequency, expected frequency, and the condition is observed frequency and expected frequency sum should be same. Okay, so still if you have any doubt, you can post your query in a comment box. I'll try to provide you the solution of the same. Thank you. Have a nice day.